And at this time, I'd like to introduce Dr. Elizabeth M. Hughes.
Hi, thank you. Thank you for joining me this afternoon. I see some familiar names on there from this morning, so thank you for coming back. I am here to talk to you today about writing in mathematics. And if you excuse me for one moment, I will, I had a little screen pop up. There we go. Or not. Okay, there we go. Thank you. Oh no, it is. Oh, there we go. So what we're going to talk about today, what I'm going to introduce to you are different ways to have students write in mathematics and write mathematically. If you were in my last session, you already saw this. If you're new, this is just a little bit about myself. And I said my two flexes here are that, actually, this is a slightly different one I have here. But my two flexes are that I substitute. So when Penn State is not in session, I go into the local school districts. And I've worked as a special ed para, as a high school teacher, as a special ed teacher, as elementary teacher, elementary para, middle school. So it's fun to be in the classroom and just really connected to what's happening in our schools. And also I am a parent, an aunt, and an advocate for children with exceptionalities. And later today in this session, you'll hear some stories about my niece when it comes to math writing. Okay, so welcome. I want to start off with a quick pause and ponder. And last session I used the chat a lot, and we will use the chat for this one too, but you don't need to type anything in the chat. This is more kind of like a self-reflection. What do you do? What do you do in your classroom? And so the first one I want you to think about is, what is math writing? And I'll answer that question too, based on what research says and what scholarship says. But I want to know for you in your classroom, what is it? Okay. Second thing, why is it important? We are an intimate group right now, but we are all here for a reason. I'm here because I love talking about writing and reading and language and mathematics. And then the third question is, for whom do we write? And this is a question when I work in elementary and middle schools with the math writing intervention that I will share with you later today. This is in lesson 1. This is one of the first things we talk about. For whom do we write? And you're going to see this in the slides and in the different types of math writing, that there may be a different audience. Sometimes I'm writing for myself. I'm writing for my own understanding, my own development. Sometimes I'm in what I look like when I'm writing for myself is going to be different, or maybe different for when I'm writing to my teacher, who has the situation and the context, but maybe wants to know specific things, which may be different from when I'm writing to somebody that I don't know, a stranger who is scoring and assessing how much I know based on how I'm communicating it. We all know I'm talking about the PSSAs here. So for whom do we write really kind of plays into this as well. The why is important. Again, that's a question that I ask students, and we talk about authentic reasons for math writing. My husband is an engineer, and it's so funny how our careers are very different, but also kind of very parallel in a sense. And when I hear him in meetings and hear him talking, explaining the science and the mathematics and why to choose this turbine combustion design versus this turbine combustion design, or use this nozzle versus that one, it all kind of ties into, well, how are you communicating your understanding, efficiency, mathematics, and then also into that science. So there's a lot of reasons why we can talk about why it's important, and you'll see some coming up. And then that first question on there? Well, what is it? Okay. Casa et al. They had a bunch of scholars, some of them who are presenting here, like Sarah Powell, and they looked at, well, what is math writing? So the overview of mathematical writing, they put it into 4 different types of math writing. The first one is exploratory. You make sense of the problem or situation. Next, mathematical creativity. Share flexible thinking, thoughts, ideas. We also have informative or explanatory, which is where you describe and explain. We see this is where we see it a lot in education, or argumentative, where you're constructing an argument and kind of pushing one side or understanding of something. And we'll see examples of all of these, but those two, the informative and the argumentative, are really the ones I think we see more in our educational classrooms. But I have examples of all of these, and these come from the publication that Casa and all did on mathematical writing. So the first is exploratory. And in this one, you're really making sense of a problem or situation. And so when I think about the audience for this one, the audience is really the self. Okay. I'm exploring this idea. I'm trying to make sense of it, see if I, in this one example, agree with it. But this is all happening in this process. So the audience is the self as you're putting your thoughts down on paper, you're reflecting on your thoughts, you're making changes, you're making sense of what's happening. Okay. Math writing, as you see here, can just be a little sentence or a little blurb. It doesn't have to be an entire paragraph. We're going to get to entire paragraphs, but it does not have to be a huge document of writing. It can be snippets. Okay. Mathematical creativity allows students to share flexible thinking. This could be for self, this could be others. You could be writing for a classmate. You could be writing about a mathematician. You could be creating word problems or creating games or any sort of thing that really looks at how you can have fun and play with mathematics. You make a mathematical poem, a book about math. When I taught 4th grade, we used the math curse. And so we read the book, The Math Curse, and then we wrote about a day in the life of our elementary classroom in all the ways that math came into it through this math curse. And so that would have been a creative outlet for mathematical writing. Okay. The ones that I said we see the most in the classroom and we see the most in assessments are that informative and that argumentative. For the argumentative, you're constructing your position on a side. Do you agree? Do you disagree? And then justify. Explain why this is the best answer. So you need to, just like if you kind of thought about in writing class, argumentative writing, where you have the intro and you take your position and you have the counter position and then you share your position, an example, counter position. These are the same things that you're going to be seeing in here. The audience is naturally somebody else because you're trying to persuade them and convince them to see things the way that you're seeing things. So this is one of the reasons that audience is important, because as you're constructing this argumentative piece, it's very different than constructing that creative piece where it's just for yourself and your own knowledge and development. Okay. Having students explain why, just adding that why and putting it into words is a way that students can begin to express in writing. Here's another example of argumentative writing. Again, these are all coming from Casa et al.'s document, and they have different places for you to fill in, and then that will, how do you know? Okay, going into a little bit greater detail with that discourse, that written discourse for your mathematical reasoning. And then the last one is the informative and explanatory. And this is the one that we also see on the PSSAs where it says solve and explain. And I think just recently they changed. So it's not, you don't just have to use words. You can explain using expressions or pictures in other ways as well. This is the one that when I see my kids' math homework, and I have a kiddo that just finished 3rd grade and a kiddo that just finished 4th grade, we see a lot of the explains. Okay, what's funny is they don't let me help them teach them how to explain. So I definitely don't wear the teacher hat when I'm with my kids. They just shut me down with that. But I love teaching other kids. So here we have the audience could be for yourself. You could be explaining it for yourself. It could be with that like kind of exploratory element where you're starting to and continuing to make sense of something as you're explaining it. Okay, you could be explaining and making connections or steps or kind of why we do different things. Not necessarily like you have to agree with me, this is why I do it or why this is the best way, but rather this is the way that I did it. Okay. And here's another example of that. It's very informative. Here's some information. You've got lots of different prompts that you can use. Okay. Here's some more. So why do we have students, or why do we want students to write in math class and write mathematically? Research shares that it really helps students make those conceptual connections and understanding. It builds their mathematical reasoning, their problem solving, and really their quality of expression as well. Just putting something down on paper, and a lot of folks in the last session when we talked about note-taking and the importance of note-taking and the benefits of note-taking, this I think has that similar aspect where we are engaging and you're putting your thoughts, you're not just saying your thoughts and putting them out there, but you're putting them down in a space so they become a permanent product. And you're able to, as you're writing it, you're reflecting and reading and rereading and making changes or connections in this process. So multiple things are going on, and you're really connecting that mental Velcro with what's happening. Okay. For teachers, there are lots of benefits. Number one, it's an interactive way for students to engage. You can use it as an assessment, but you don't have to use it as assessment. It can be used as an assessment. It can be used as a learning element. So like as the process of learning, writing to learn. You could look at it through an error analysis and really kind of get into your students' minds. So if a student's making a mistake and they're able to express in words, either orally or in writing, their process, you're able to see where any disconnects may lie. Okay. And then the last one I have here is you can target instruction for improved outcomes. So you can really kind of help focus and change your instruction based on what you're learning about students and how they learn and what they know and what they understand through their writing. So that's a lot of information. I'm just going to pause right here for a second. I'm going to make sure that I open my chat. I do see that I have a direct message. The question I have was I'll kind of paraphrase. Sometimes it's so frustrating when we require students to do these tasks like make their own math problems or solve and explain. If we're not really teaching students how to do that, and we're definitely going to get to that, Jen, later on, how we have these expectations, but we don't really teach students how to do them. And that'll go into the story with my niece as well. So any other thoughts, questions? Okay, excellent. Okay, then it seems like other folks have the same concerns. We will keep going then, because I'm going to get into the how-tos for that. Okay, so we know it's important. Here you have it here. It provides that permanent product. It gives students time and space. We also know it's important, and and CTM recognizes the importance. This CCSM recognizes the importance. Pennsylvania recognizes the importance. We all want students to be able to understand and talk about math. Okay. Where do we fit it in? This is really going to depend on where you do it in your curriculum, what the expectations are, where the gaps are within instruction, and how you want to fill those gaps, basically. So I want you to think about a typical unit or a typical lesson. And Jen and Gail, this may go into your questions as well. What are students required to do? What writing are they required to do? And how do you teach or address that writing based on your curriculum? Okay. To optimize these outcomes, we want to make sure we're deliberate, connected, and explicit. And this ties into it. Here are lots of different forms of writing. Okay. Take a look at this. In your current curriculum or the way you're teaching right now, how many ways do your students engage in math writing? In the chat, here's our first time to really use the chat. How many of these do you do? Or do you have any favorites? Okay. How many of these, how many of these ways do you have students write? Or have you seen students write? Or does the curriculum have students engage in writing? Could you even think of these as writing? Okay. Okay. Excellent. Thank you, those of you who are sharing. We're going to shift now. So we've kind of talked about like the benefits of writing, what is writing. I'll go back because I see lots of numbers coming in now. Next, we're going to shift into ways to engage writing. And just like with the other presentation where I try to share things that you can really come in at any angle or any level or any readiness and take something from the presentation, I'm going to try to do it here as well. And Gail, we can talk too, because I think that's really interesting. And that I think some of that goes, what you just wrote there goes beyond the scope of this. I think you can, especially with exploratory, really work on the foundations of math and numeracy while writing. But there are ways that writing can support that as well. So I'm going to start at kind of that word level. And if any of you were in Sarah Powell's presentation earlier today, she talked a lot about mathematical language. So let's take a look at this. Okay, and this is a real life example of mine that I was a part of this, and not in the best way. So, okay, in the chat, who can tell me what the answer to this is? Anybody? Okay. I'm not seeing any answers yet. Let me read the story to you. Sarah had $187.53 in her bank account in January. If she had SAD-bus $66.93 in March and LogCat Sam cut $25.50 in April, how much money does Sarah have in her bank account at the end of April? Okay. Oh, you need definition of LogCat Sam cut. Excellent. So there are 37 units or words in this word problem. Okay. You can read, or if you heard me, I could read all of them. Those two unknown words were decodable. So if we follow that decoding thing, I know comprehension is 95% of this problem. Okay, I can comprehend 95% of this problem. However, in mathematics, that's not really enough because it really depends on what those words are and what those terms are and how they are used that matters. We all teach reading, absolutely. So this was a true story. I was tutoring a 7th grader and we're going over this. And she's like, I can't solve this problem. It said deposited and withdrew. And I'm like, yes, you can. We've been working on this all week. Like, you can do it. Like, motivation, like really strong motivation there. And she's like, I can't. I'm like, yes, you can. And she said, I don't know what deposited means or withdrew. And I was like, oh, I work with language and mathematics. It's a language problem in this case, not a math problem. Okay, it wasn't the calculation, it was the mathematical language that the student was having trouble with. And that makes sense because we have so much vocabulary. Again, this probably reflects, if you were in Sarah's presentation, she talked about that. And the importance of clear and concise mathematical language is super important. So how do we support vocabulary? We can do this through writing. And I know some of you said you did attribution charts and tables. This is the first one that I will be sharing. Okay. When we talk about language, we have receptive and expressive language. When we're talking about written expressive language, that's really where we're talking about writing. So you can have an attribution chart. This is math writing. This is an easy way for students to draw, list, write things related to elements of mathematics. Okay. Another way to engage students with writing is through the Frayer model. Oftentimes when I'm talking to teachers, they're familiar with the Frayer model, or they're familiar with using kind of a graphic organizer such as this to talk about and write about mathematics vocabulary or concepts as well. So I'm not going to go into like, oh, this is exactly what you do in each box. It's kind of self-explanatory. What I will say is that I think it's super important, and research shows it's super important that you teach students how to engage with this. Okay, it's easy to say list examples and non-examples and definitions and characteristics, and they're the word. Boom, I'm done. Okay, doing it effectively is going to be more than just that, or more purposeful than just that. Okay, so this is how I recommend doing a schematic like this, or using a graphic organizer like this. Start with the word, for the concept, whatever you have in that central area. Then go right to examples. Logically, like when we see something like this, we think, okay, got to start top left. That's what we do. We read from the top left. We start from the top left. We're going to start with the definition. If you start with the definition, especially if you start with the book definition, you are going to lose most students. Okay. That is not the easiest access point. Sharing examples or facts or characteristics is the easiest point for students to access this information. It's the easiest information to add and get correct for all students. Okay, so we're taking like little steps into this. So you start with the examples, easiest access point. Then, okay, let's look at these examples. What do these examples have in common? What can I deduce from this, these facts, these characteristics? What else do we know about this term or this concept that we can list in that second quadrant there, the facts and characteristics? So we've started with the easiest access point. We've connected it and expanded it. Then you go to the definition and you say, okay, let's put the definition in our own words. Based on these two things that we have, let's put the definition in our own words. Then let's write the book definition and compare. How close is my definition to the book definition? Do I have the same salient information that they're sharing in the book? but in a much easier, kid-friendly way of sharing it. So then we have all that. The last quadrant is those non-examples. And this is really important. And sometimes we like breeze through these or forget to do these because they're not part of the curriculum, but having non-examples helps you set the parameters. It helps to prevent overgeneralization, and it helps to really determine when and how we use this term and concept and when we don't. Okay. Oh, sorry, I have any of you see that I have definition. I have an error on here. So I said go to non-examples third and then the definition. But then on the quadrants, I have it listed differently. My apologies for that. I would actually say go to the non-examples, then do the definition last. But as long as you start with examples and facts and characteristics, you can do whatever works best for you and your students, whatever's easiest. After you've had students writing and creating these, the next thing you want to do is talk about, well, once we've written something, like how do we use that? Are you going to use it for notes? Are you going to use it to study for the test? Are you going to use it to hang in the classroom as a reference as students are learning new information? So now we have not only that the students are writing and engaging in this writing and making connections, but we're learning how to reflect and act on that. And then I have some examples here. So this is one of those activities you could do tomorrow if you wanted to. There's not a lot of prep. I would recommend that you think about examples and non-examples, things like that. Pick the terms that are most important, or pick the concepts that you historically know that the students are having extra difficulty with, or they're learning now and they're absolutely going to need it in Algebra 1 and Algebra 2. So you really want them to learn it and understand it at a deeper level. Okay, you can't do this for all the terms. We run out of time, but you run out of mental capacity, but do this for the ones that are most important. Okay. The next one is prompted writing tasks. And I love, love, love this one. This is another one that you can do pretty much tomorrow. You could walk in tomorrow and start doing it. Okay. In a prompted writing task, and actually let me bridge. So that was, we talked about vocabulary terms and how to write about language in mathematics and understanding concepts in mathematics. And that was very much like a list, draw, word kind of level introduction to writing. Okay. Very important. That's one thing that you can do. Now we're moving into kind of more comprehensive, more sentences, kind of applying the vocabulary that we developed in that first area. Okay. So in the prompted writing task, you have a writing prompt and you have scaffolded language. This is really important because it takes that cognitive load off of students. And I know they talked about cognitive load in the initial keynote. So it takes that cognitive load, it removes that so that students can focus on applying that. So I don't have to recall certain words. The words are here for me. I can now remember what they mean and apply them. Okay. The top example is that I have here on this slide is one from Paul Riccomini. When he was working with teachers, he taught them prompted writing tasks, and this is what the teacher came up with. Okay, so write at least 3 complete sentences about the term absolute value using the following terms. And then the teacher created a rubric as well. Okay, the one on the bottom is part of the Prism math writing series or strategy that I'll share with you later. And this just has the solve and explain your reasoning, but use these terms. So it's connecting, like when solving this math problem or this open response problem, these are the terms you're going to use. So it's kind of like little arrows and directions and scaffolds to support student learning. Okay. Essentially, this prompted writing tasks help to explain different elements. Now you can embed them with different evidence-based practices as well. Okay. So in summary, and I'm sorry, I think I had that slide out of order. In a prompted writing task, you give students 2 to 5 key terms to use. And then here's another example. What I also love about this, these I've created in advance. You can have 5 words, you can have 2 words. This is one of those ways that you can differentiate. You can put the words up on the board for students who may have difficulty processing what's on the board and bringing it to the paper. You can put it on a Post-it note. You can have students write down their own 3 words on a Post-it note, or, and this is my favorite little hack, you can take those labels, the ones that you can print off in the printer, and it can have those terms on there. So you can, in your own curriculum, in your own student workbook, if they have a solve and explain, you take that little label sticker that you already have those 3 terms on, and you just stick the sticker on the book. Okay, and you've scaffolded the response, and it ties right into what your district already uses. Okay, we're reducing the language load for scaffolding. Thoughts, questions, comments? Question is, how much depth per word do we need? I will say that completely varies based on the term, based on how often they're going to use it. I would pick the ones that they're going to see most often, that they really do need to understand. But I would look at, 3 sentences for that one term. I think it was 2 to 5 terms, and they could use multiple sentences. This may be the slide that to which you're referring. For depth for the terms in the responses, if they're using it correctly, they don't have to define it as long as they're using it correctly. This may answer your question, Jen. So you could say, like, the prompts could be write about fractions using these terms. All of those open responses that we talked about, if you were at my previous session, these would be a great way to kind of scaffold those as well. Talk about this. Here are some terms that I want to see you used. 3 sentences for one term. I can talk to you after about this too, because I think there's so many ways that we can adapt this to kindergarten. Okay. And sometimes we think, well, kindergartners don't know fractions, or they don't, they can't use words like denominator. And if they can say, like, Diplodocus or Diplodocus or Tyrannosaurus Rex, or any of those dinosaurs, they can say denominator. So I think using these terms and giving them opportunities to explore with these terms might be great. Equitable for ELLs. I love that question. It can absolutely be used with ELLs. You could put it in both languages. I mean, I think when doing these prompted writing tasks for ELLs, I was working with a district in Texas, and it was a majority Spanish speaking district. And one of the things that we kind of talked about is like, well, what is the purpose? If your purpose for students to write is to learn the concepts and to understand and make sense of it, I don't care if they're using English or Spanish, or if they're translanguaging kind of back and forth within this. And then we can scaffold to English for assessments. But if they're making sense of the concept, you can do this. If they're making sense of the concept, and then connecting it to English language, this is a great way to do that as well. Okay. But I can share some specific examples with you later as well. And that's the one. So this, I think, goes back to your question, rate 3 sentences about the term absolute value. And then they gave them those things. So the term was broad enough that they could explain it multiple ways or give different sentences for that. Okay. Here are some more of those story starters. For kindergarten or even early elementary, they can draw a picture. You can have terms written out and they can kind of sort those and do those sort of things as well. Okay. Here's another example. Looking at when you're using heuristics and using those terms, you can provide the terms and the definition of the terms if you want. When teaching any of these and introducing any of these for the first time, I would make sure that I'm doing it explicitly by modeling multiple examples, by then moving towards that guided practice before moving into independent practice. Okay. You can also incorporate math writing into other evidence-based practices. For example, worked solution strategy, which I think Paul Riccomini may be doing tomorrow, maybe here. In a worked solution strategy or work solve solution, the problem is already solved for the kiddos. Okay, you've taken away the cognitive load of solving and getting the correct answer, because math is more than just getting the correct answer. Okay, so you've broken down the steps. You've shown students how to do this. It's either fully solved or partially solved. Thanks, Allison. And then what you're going to do is draw students' attention to what's happening in between those steps. So what is the connection being made? Okay. For example, here you have a worked example, and the directions say, study the steps on how the equation is solved. For each step, think about what has been done and why it works. And I'm going to tell you right now, talking about the why it works tends to be the most challenging for students, which is why those scaffolded use of terms are important. Okay, for this example, what you're going to want to do is draw students' attention to what's happening in each step. You're going to want to model why and what. Okay, so you're going to walk through each one. You're using all that metacognitive teacher talk. You're making the connections. You're saying, what do I need to do? The first thing I need to do is think about getting all of my variables on one side. How am I going to do that? Talking through those elements. And when it comes to writing, not just talking through those elements, but then putting them in written form. Okay, so this is a table that I created for this example. We're saying, okay, what is happening from A to B? And that's going to go in this box right here. And then why we can do that goes here. And it's just a sentence or two. Okay, so what's happening? These are the procedures. Why is it happening? That goes into the rules and the concepts and the understanding. Close that up. Here's another way of looking at it. Thanks, Ken. This really breaks it down for students, using writing with these worked examples. And one of the reasons I like connecting writing to worked examples is because, like, let's be honest, if you say to an 8th grader, look look at how this it's solved, like study the steps. They're going to look at it and be like, yep, okay, makes sense. And then you're going to say, okay, why does it make sense? And they're going to be like, I don't know. So kind of really breaking it down and saying, okay, what's happening here? Why is it happening? Helps to kind of take something that's really big and focus it and narrow it. Here's another example of that. In this one, I added that draw element, which goes into that concrete representational abstract sequence, or using visuals to help make sense. And I will say, and this I think is going to come up later too, research shows that when students draw a picture, they are more likely to get the answer correct. So in research that we did on math writing, when students drew something, so they had a word problem and they drew an image or a figure or something, a heuristic, they were more likely to solve it correctly. And they were more likely to explain it better. Okay. So for this one, you can scaffold it as well. You can say, oh, dividing by fractions is really hard. I'm going to draw the picture, or I'm going to kind of break it down the steps why we flip and multiply. Okay, we all know to flip and multiply. Well, why do we do that? So breaking those down. Okay. So that is the section on kind of guided prompts. So we talked about kind of looking at more of those terms and those words and really expanding understanding of vocabulary. And using the Freire model does work for English language learners. There is research out there that it supports students with learning disabilities, students with ELL, and you can, I think, really kind of connect it in both languages. And then we looked at the prompted responses. And now we're going to look at open responses. Okay. And so we need to give students time to do this. And this is one of those things that I think curriculums have this in there. They have the solve and explain, but they don't explain how to do it. Okay. One thing you can do is help students better understand representations. Students who draw representations are more likely to solve the problem correctly, but there are different ways to show understanding of a problem through a representation. So talking about and writing about that argumentative writing about why somebody's representation may be better than another is a great open response to help students understand examples and non-examples. And you can do this with errors, common errors that students may make. Okay, this is an example from the Prism strategy that I'll show you later. So this is one of the things that students do as part of that. Okay, already talked about this. Now I'm going to get into the Prism Check strategy, and I'm going to spend, I guess, probably the next almost 30 minutes talking about this. This is going to get into a lot more of the how to teach students to write. Okay, some of the other things you're going to want to show them how to use the guided prompts and show them how to use the Freire model. But this is really the pulling it all together. Or so I think. I created this. So it is my little baby here. But what I have been working on since 2016 with the help of Paul Riccomini and some of my doc students is this strategy for math writing called Prism Check. Okay, and you can see a picture here of my early iteration of what Prism Check is and how to use it to support student writing. And what I love about this example is the student chose to color code everything. Okay. Prism Check is I'll say it's a strategy that works best for the solve and explain. Okay, and I'll show you in a few slides. We did do research with this, and it correlates with, and it supports using the rubric that the PSSA uses for their open response problems. And we modeled many of our examples off of their open response problems. So it is an SRSD math writing intervention or strategy. What does that mean? Pulling from the writing side, we really looked at, well, what do good writers do? And what do good evidence-based writing interventions have in them? And so SRSD, self-regulated strategy development, has a really strong research base. And those are those 6 things there with the green arrows going down. In SRSD, you develop background knowledge, you discuss the strategy, model the strategy, memorize the strategy, have collaborative practice, which is a whole bunch of different kind of guided practice, and then move to independent practice. And then we also looked at, well, what is really key in evidence-based practices within mathematics? And so you have explicit instruction, which is a huge evidence base, using heuristics, or those visuals, not just representations, but graphic organizers, different ways to visually support understanding of the math vocabulary, purposeful practice, and then also visual representations, or concrete representation, abstract representations. Okay, so we looked at what's writing, we looked at the math, and then I squished it all together in what we call Prism Check. And I think every good strategy needs a great mnemonic. And so Prism Check is that mnemonic for me. Prism Check stands for problem, representation, I do, state, say, and share why. My answer is check my work. Okay, this mnemonic prompts students to go through all of these elements, and they learn about these elements as they're applying them to their written responses. Okay. We have done lots of research around this. Here are some of the publications that I've worked in 4th grade, 5th grade, 6th grade on applying these. And over the process, I've continued to improve this. I'm on sabbatical this year. I'm going to be working on kind of finalizing it and making sure that everything's really up to date. And then I'll be willing to share it, and we'll be able to share it through Patton as well. So this is, again, early elements, but I picked this because this shows both the PSSA and a rubric that we created. So you had the treatment group and the control group. What I want to emphasize here, first of all, take a look at the margins, because this looks like a huge gap. This is not a huge gap. I'm going to be very realistic here. Make sure you're looking at the scale for understanding. But both groups that received the Prism Check and students that just wrote about math improved with the opportunities to write about math. Just writing in mathematics with no instruction, just opportunities to write, should increase students' understanding and expression. Now we've added this instructional strategy piece, and it has increased even more and at a greater rate. Okay. What we did with this is on the top, I have here the PSSA assessment. So this is what PSSA uses, that 0 to 4 score. I am not digging into or just dissing PSSA. I think this is probably a very effective rubric for scoring a lot of prompts. However, it doesn't really give a lot of information to support instruction. So we really broke it down, and the rubric on the bottom is what we used in the studies. And it shows, you can see a lot more where you can kind of target and support students in the classroom. Okay, and these two did correlate. So students who, when we use the PSSA rubric, tended to do better, also tended to do better when we use the Prism Check rubric. And here's a different study where we show, again, there is growth with both of them, but when you have students and you're teaching them the strategy, it's a greater growth. Okay. So I'm going to pause, leave this up here just for a second. I will go through the different lessons. One of the things that is really important is sharing those examples and non-examples. And even with the examples that we're like, oh, this is a great example, students can like find ways to improve it. It's very fun. Okay. Here's another example of just that pre to post after we teach students how to do something, how they can apply it and show improvement. Okay. Excellent. Questions, comments, thoughts, concerns before I continue? We're going to get into the heart of it now. Awesome. Okay, so once I refine and improve the script, I will be willing to share it with everybody. We have it at that 4th, 5th grade level, and I'm working on creating one for a 6th and 7th grade level too, with problems more applicable to 6th graders and 7th graders. But you can even kind of apply this strategy without the script as well. The first thing you do is introduce the strategy. Okay. The first day we don't do any math. We don't do any writing. And I've been in the classroom like teaching this. This was one of the first few studies that we did. I was the one teaching this. So we talk about why is math important? Why is math writing important? Who are your audiences? Those first few questions that we had. We then talk about the strategy. Here's a strategy that's going to help you improve your math writing. And we break down each of these parts. We talk about the problem and what does it mean when you address a word problem? And what does drawing a representation mean? And I do mean solve the equation. How do we write an equation that matches what's in the word problem? And S stands for state, say, and share why, which we'll get into in greater detail. And then M is, well, that's that closing sentence. That's my conclusion, and then checking your work. So we talk about all those things and how good math writers kind of do all those things. And that's lesson 1. We don't do any math and we don't do any writing. Lesson 2, we look at examples. And the students, it's so funny because students love to like be critical of other people's work. So students were very critical. Even when I was like, oh, this is an exemplar, they're like, well, they could have done this, 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 and this. But it's great because we talk about when like the purpose for communicating. And even if you think you have something really good, there may always be ways to improve it. And we talk about, well, is the reader understanding the same thing that the writer wanted them to understand? So there's a lot of great conversations here, and you're really just analyzing examples and non-examples. Okay. In lesson 3, we get into the problem and how to attack the problem and how to pick out, and I know so many different mnemonics and ways to address the problem and really pick out what the most important information is, address what the question is asking, and what numbers and information you're going to use in solving the problem. Okay, so I had students circle the important information and underline the question, because then we'd use that later on. Practicing the parts is the representation and I do. I used to have these separate, and students just constantly had to do them together, or they would try to write the equation without drawing a representation. So you must draw the representation before you write the equation. Here's my niece, the story about my niece. She is twice exceptional. She has dyslexia and is gifted in mathematics. In 3rd grade, they had solve and explain, and she was having a really hard time because of that language element. So my sister decided to work with her, and I'm like, Nicole, like, this is my wheelhouse. So I gave her the strategy. It was still early in its iteration, but I'm like, work with this, do this with her, teach her this mnemonic and these steps. So she did, and she came back and she's like, Elizabeth, it didn't really help. And I said, okay, so we went step by step. Did you do this? Did you like look at the problem? And she's like, yeah, she did that. I'm like, did you draw representation? And she's like, no, she knows how to solve the problem. We didn't draw the representation. We don't need that. And I said, stop. You do. Drawing the representation is not just so that you solve the equation correctly. Although I said earlier that students who draw the representation are more likely to solve the problem correctly, but drawing the representation really provides a visual for that conceptual understanding of what's happening in the problem. Okay, depending on what representation students have, they may conceptualize it in different ways. That's okay. But that representation then links to the what they're doing and why they did that and how it makes sense. So Sarah started doing that. And then her third grade teacher started using her word problems and her responses as the exemplars in class. And this is how to do it, which was so exciting for Sarah because language and reading and writing was such a problem for her and a challenge for her. Lesson 5, you go into state the problem. This is simply, if you're going to do this with your students, we take the question and we rewrite it as a topic sentence. I've had discussions with people before. Do you really need to rewrite it as a topic sentence? Is that really essential to students' understanding? My stance on this right now is we don't know. We don't know how much value added it is, but as a teacher, it allows me to know, did the student know exactly what they were supposed to do? And it's also that point that you can go up to and be like, okay, this is what you said you were going to do. So if the question was, how many dogs are at the dog park? You would say, we needed to find out how many dogs were at the dog park. Say what you did. This goes into that addition, subtraction, multiplication, division. What did you do to solve the problem? Not what are the steps of long division, but that you needed to divide. Lesson 7 is the most challenging. This goes into why. And I'm going to give a shout out right here. If you, for next session, word problem, no problem that Sarah Powell is doing, she is going to go over schema-based instruction. That is what we do, a modified schema to share why. So when teaching addition, subtraction, or multiplication, division, we really connect into that schema because we say there are 3 reasons why you add or subtract. There are 3 reasons why you multiply or divide. So putting into words and knowing why you're doing that can help with this share why part. Lesson 8, because the sharing why is so challenging and it might be a great place to scaffold that language. Then we add that closing sentences, which is my answer is, and students have to label. Then we bring it all together and we have students practice individually with peers, all of that. And I think I'm going to have enough time. I will show you the scripts that I have so far so that you can see this in action a bit more. Okay. So there are lots of reasons why we write. I'm going to close up this presentation and open the script so I can show you those student and teacher ones as we talk about open responses. But as I'm doing that, are there any questions? If you have questions, thoughts, comments, concerns, things you want me to go into in greater detail, please let me know. I'm going to pull up those scripts so that you can see that side by side how we taught students to write in mathematics using Prism Check. Okay. I'm going to share my screen again. Oh, I see a question. Okay. You should be able to see at this point, I have the teacher guide and the student guide. And so the question is about cognitive load. This is where I kind of provided the overview through the steps, but we address cognitive load a lot in here in the individual lessons. So for example, here are, and these lessons are slightly different. This is the updated version, and we added more vocabulary scaffolds as well. We have this semi-script. I like to think of it as a more like a Goldilocks script, because you don't have to read it word by word, but it provides those supports so that you can follow along. I have when students are doing something, when the teacher's talking, when the students are discussing, and then the student workbook corresponds with that. At the beginning of each lesson, you have the objective, and then we have students write positive self-statements and set goals. So as part of lesson 1, you're talking about what is the mnemonic. The students are going to write it up here. Here they write it in their own words. They write the different letters and what word they connect to, and then on the bottom line, what that means. Like, why do we want to do problem? Well, that reminds me, I really need to pay attention and be clear about what's in the problem. Representation, it reminds me that I need to draw a picture that makes sense with the problem. I think the student book is more interesting. And then we kind of scaffold it back. The next day, students write it again. We do positive self-statements, we check their memory, and then we have the examples and non-examples where they go through and they look at with a different color. Did this example address the problem in red? Does it have the representation in orange? The equation in yellow, and all those steps. The little rainbows on the bottom, students would color those in. And this was really neat too, because they would, depending on how well it was done, would be determined how much they colored in. And so sometimes they'd color just a little bit in, or they'd color half of that arc in, depending on how what they thought was in the example. Okay. We went through lots of different examples. I provided ample examples so that teachers could use more or less depending on what they need. Okay, so this is going to be a sadder rainbow, as my 5th graders called it. They're like, oh, it's a sad rainbow. It's not colorful. Okay. The next problem we look at, well, just how do you read for understanding? How do you examine the question? And how do you determine the important parts? This will later tie into schema. For representations, we spend time just talking about representations. Okay, I have a lot of examples in here, which are, hey, here are different ways to represent it. Which one makes sense to you? Okay, they're not even doing the math right now. I've provided all the math. So Gail, this kind of goes into some of that cognitive load with the math. We're just working on that specific part. We're not pulling it together until the end. So looking at, okay, well, there's the problem. We've already kind of talked about how to address the problem. So they would be applying that now. And now we look at the representation, and then they can write up as the equation. And then we have some self-checking there just for reference. Okay, then we scaffold it back, draw your own representation. And we have different problems. Teachers can always provide a representation if there needs to be greater scaffolds here. Okay. For state, we just talk about, again, just that cognitive load. We just want to focus on something very specific. So we're talking about, here's the question, how do you turn it into a topic sentence? Okay. Question, topic, sentence. And then they can kind of create their own. Say what you did. Again, we've scaffolded it where we've solved the problem for them. So that cognitive load that is gone. They just have to explain, okay, well, here we divided. To solve this problem, I divided. Okay. Here I've scaffolded some other terms as well. I've done the sentence starters. You can add more sentence starters if you want, because we're working on the stating what it is. I've done the topic sentence. So again, to reduce that cognitive load. Okay. Thank you. It takes about, and I know I'm running out of time, it takes about, I'd say 30 minutes for each of these lessons, but that depends as well. It depends on how you're doing it. Okay. Here we're talking about, this is where the schema comes in. So if you're interested in schema, I highly recommend going to Sarah's presentation. She will do this, but even here we've scaffolded, because we're not doing the whole schema intervention. We're just kind of like connecting it here, but we've scaffolded it in the language and with the representations. Okay. So I know I'm running out of time. So some people just asked about where to get these materials. I'm currently updating these materials. So if you want these materials, I did talk to Jared prior to this session. And once these materials are ready, I'm going to talk to Patton, and we can go through Patton and we can share these materials, and I can do kind of like a professional development training to really go into this in greater detail with what to expect and how to use the teacher book as well. Okay. So there are lots of different ways to do this. I'm gonna, for sake of time, fly ahead a little bit. And see if I can get some of that language. Okay, so here are some of those math terms. So after students put it all together and we're doing this, we still scaffolded some of the language here. I love that some folks want these, and I want to get them into your hands as soon as possible. I just have to fix errors, and I have to like, this is my sabbatical project. So I want to make sure that like the word problems are more relevant, things like that. Okay. I am like out of time. Questions, comments, concerns, and Gail, I can hang out and chat with you a bit more, because I know you still have some concerns about working with ELLs and stuff. Yes, with practice, they do get faster. You also have my email. If you have any questions, feel free to email.
Dr. Hughes, is there anything else before we close out the session and give everyone the exit code?
Exit code, and then no, feel free to email me if you want any of the things that any of the prompted writing tasks or things like that, or if you have questions, feel free to email me. Yeah, thank you very much for coming and staying.